Welcome to Study Loop.
19.65. So we have a battery with an EMF that we're trying to find. We've connected two resistors in parallel that are both 9.4 kiloohms. And we've connected a voltmeter with a sensitivity of 1000 ohms per volt and set to the 3 volt scale. And we're measuring 1.9 volts here. And so we want to find, I already said we want to find what the EMF is, given these things. So to begin with, the resistance of the voltmeter is the full scale reading, 3 volts, times the sensitivity, 1000 ohms per volt. So this is 3 kiloohms. Now what we need to do is find the equivalent resistance here, and also the parallel resistance of the voltmeter and the resistor it's measuring. Which we can call RP for parallel. So this is our familiar equation for two resistors in parallel with one another. R plus RB. So the parallel resistance here is 2,274 ohms. Then the total equivalent resistance is that plus the resistance of the remaining resistor. We're told to ignore any internal resistance of the battery. So this is 11,674 ohms. So we want to find the current into the parallel combination here, which is the current that the battery is delivering, because the current from the battery goes here and then into this parallel combination, and we don't really care how it gets split up between the two. So that current is going to be the voltmeter reading divided by the resistance of the voltmeter in parallel with the resistor we're measuring. Recall V is 1.9 volts, and we just found what R sub P is. And so this is 835.5 microamps. And now the EMF of the battery is going to be the current times the total resistance that it's moving the current through. We found basically, if you knew what the total current was, then you could find the voltage here, but we're given the voltage instead, so it's maybe a little bit backwards from how we're used to thinking about these things. And so we know our current, we know our equivalent resistance. And so that gives us a battery voltage of 9.8 volts.